So there are 4 types of inequalities that you need to know. The first, we have less than, which also means fewer than. We have less than or equal to, which is a less than sign with a little line underneath it saying that it's also equal to. This also means no more than or at most. Then there's greater than, which means more than. And then finally we have greater than or equal to, that again has that little line underneath it to show that it's also equal to. This means no less than or at least. So to solve an inequality, we're going to solve it just like we were solving an equation. We're going to start, of course, by drawing that line down the middle of the equal sign, and then using the opposite operation to move the numbers to get the variable by itself. So on this one, we're trying to solve for that x, and we have to move the 2. So in order to move it, I'm going to divide both sides by 2. That's going to give me x is greater than or equal to 6. So this is actually my answer. What this means is that x can be any number that is greater than or equal to 6. So basically we could say x is 6, 7, 8, 9, we could continue on. Now there's no way we could write all of those numbers out, so the way we show it is to either write it like this or draw it on a number line. When I do the number line, I'm taking a snapshot of it. So I'm going to start by putting 6 in the middle here, and then moving a couple in each direction. So if I move a couple to the right, it would be 7 and then 8, and then to the left would be 5 and then 4. Now you have 2 things to decide when you are graphing an inequality on a number line. First of all, there has to be some sort of point or circle at that 6, since that's the number that x is greater than or equal to. We also have to determine which way we're going to shade to represent this inequality. Alright, let's start with talking about the circle. First of all, we have 2 options. You have an open circle that's not colored in, and a closed circle that is colored in. Now, an open circle is not equal to. That means that we could have a less than or a greater than sign. Basically, it's not going to have a line underneath it because it's also not equal to. A closed-in circle is the opposite. A closed-in circle means that it is equal to. So we're going to see either a less than or equal to sign or a greater than or equal to sign. So basically, when it has that line underneath it, it is a closed circle. So what I'm going to do is I'm going to draw this number line, or draw on this number line. We're going to put a circle at this 6, and because it is equal to, greater than or equal to on this one, I'm going to color it in. The second thing we have to decide is which way do we shade. Do we shade towards the 7 and 8 on the left, or on the right, or do we shade towards the 5 and 4 on the left? Well, I found out from my inequality x is greater than or equal to, which means it has to be a number larger. So that means I'm going to shade to the left, representing all, or I'm sorry, to the right, representing all of the numbers that would be greater than or equal to 6. So this would be how I depict my inequality by graphing it. Okay, let's do a few more so we get the hang of it. So this one we have 8 plus 3x is less than or equal to 2. On this I'm going to start by drawing that line down the middle again. And here, sorry, this should be a 2x. Here I'm going to combine first my x's together. So we have a 3x and a 2x. I'm going to move this 3x here to join the 2x over here. So I'm going to do that by saying minus 3x here and minus 3x here. Alright, once I bring everything down, this cancels out, so I have 8 is less than or equal to 2x minus 3x is a negative 1x. Now last step here would be to divide both sides by a negative 1. Here's where it gets a little interesting. This is a rule that you'll have to remember for graphing inequalities. Anytime you're dividing by a negative, the sign flips. So we're going to go ahead and divide by like normal. 8 divided by negative 1 will be a negative 8. But what happens here is instead of being a less than or equal to sign, it's going to flip to be a greater than or equal to sign. So in this case, we have negative 8 is greater than or equal to x. This is our answer, our solution to our inequality. Now we're still going to graph it. I'm going to start by graphing it on the number line. That negative 8 goes in the middle, and I'm going to move a couple in either directions. So if I move to the right, it would be negative 7 and then negative 6. And if I move to the left, it would be negative 9 and then negative 10. Okay, remember we have to decide 2 things. First of all, whether it's an open circle or closed circle at negative 8. Because it has this little inequality sign that's an equal to with it, it is going to be a closed circle at 8. So I'm going to go ahead and put a closed circle. And now I have to decide which way I'm shading. So we have negative 8 is greater than or equal to x. That means x has to be smaller than negative 8, which means negative 9 and negative 10 would be my smaller side to this number line. So I'm going to go ahead and shade in this direction to the left, and that represents all the numbers that are smaller or less than negative 8. Alright, let's try this one. So we have 4x plus 3 is less than negative 13. So I'm going to go ahead and draw my line and start solving this inequality. So the first thing I can move away from the x is this 3 here. I'm going to do that by subtracting it. So we have now 4x, 3 minus 3 cancels out, so 4x is less than negative 16. And then finally to solve, I would divide both sides by that 4 in front of the x, so I have x is less than negative 4. Now understand, this is not the same thing as dividing by a negative, it's a negative 16 divided by a positive 4. So the sign doesn't flip here. So I'm going to graph this. I'm going to put a negative 4 in the center here, move a couple in either direction. So to the right would come negative 3, and then negative 2. To the left would be negative 5, and then negative 6. So if I graph this now on my number line, I have to decide open circle or closed. Well, since it's just a less than, not a less than or equal to, it's going to be an open circle at that 4. And then because it's smaller, I'm going to shade to the left. All the less than, remember, gets shaded to the left. That represents the negative 5 and negative 6 are smaller than the negative 4 on a number line. Alright, so this one, number 4, we have 7 minus 3x is greater than or equal to 22. So to solve on this, I'm going to start by moving the 7 on the side with the x. I'm going to move that by subtracting 7 from both sides. So now I'm going to bring down my negative 3x is greater than or equal to 22 minus 7 is going to give me 15. And now I have to divide both sides by that negative 3 in order to solve for my x. And remember, we talked about when we divide by a negative, this sign is going to flip. So this is actually going to be x is less than or equal to negative 5. So this is my solution written out algebraically. I'm also going to graph it. So I'm going to put negative 5 in the center here, move a couple in either direction. So to the right we would have negative 4 and then negative 3. To the left would be negative 6, negative 7. And now I have to decide open circle or closed. Well, it's going to be a closed because it's equal to as well. So it includes the negative 5. And then because it's less than, I would shade to the left towards the smaller side of the graph. So this would be my solution graphically for number 4. Alright, for number 5, we're going to start on this one by combining my terms together. I have a positive 6x and a negative 2x that need to be combined first. So let's bring that 10 down. 6x minus 2x is going to leave me with a positive 4x, and that's still going to be greater than 50. So now from here I'm going to start by subtracting the 10 from both sides. So that leaves me with 4x is greater than 40. And then finally I'm going to divide both sides by that 4 there. So x will be greater than 10. This is my solution written out algebraically. So to graph it, I'm going to put 10 in the middle. I'm going to move a couple in either direction. So we would have 11 and then 12. And to the left would be 9 and then 8. We have to determine if it's an open circle or closed. Since it's x is greater than, it's going to be an open circle at the 10 and all numbers larger than 10. So I would shade in this case to the right to represent all my numbers that are larger than 10. Okay, so on number 6, we have to use distributive property first. So before I do anything, I'm actually going to distribute that negative 2 to each part of the parenthesis. So we have negative 2 times x is going to give me negative 2x. Negative 2 times a positive 3 is negative 6, and is still greater than negative 22. So now if I want to solve for the x, I'm going to start by moving that 6 from one side to the other. So this is going to give me negative 2x is greater than negative 16. And then finally I'm going to divide both sides by a negative 2. And remember, when we divide by a negative 2, I'm flipping that sign. So this is actually going to be x is less than a positive 8. So this is my solution. So I'm going to now draw it on my number line. So I'm going to put 8 in the middle, move a couple in either direction. So we'd have 9 and then 10 to the right. And then on the left we would have 7 and then 6. So if I want to graph this, I have to determine, first of all, if it's an open circle or closed. It is open this time because it is not equal to. And because it's now less than, I'm going to shade to the left. So all my numbers that are smaller than 8. Alright, number 7, we have a fraction. We have 2/3 x is greater than 10. So I'm going to go ahead and draw this line down the middle. Now, anytime I have a fraction, I have to get rid of it first, pretty much by removing this denominator here. So in order to remove the denominator of 3, I'm going to multiply both sides by that 3. That way I'm going to cancel this out. So I'm left with then 2x is greater than 30, because 10 times 3 is 30. And then now it's back to a normal problem, so I can divide both sides by 2, and I have x is greater than 15. So this is my solution on 7. I'm going to start by putting my 15 in the middle here, moving a couple in either direction, so we'd have 16 and 17 on the right, and then 14 and 13 on the left. So to decide here whether it's open or closed, I'm looking at my inequality sign. It's a greater than, so I'm going to put an open circle because it's not equal to. And because it's greater than, I'm going to shade to the right to show all of my numbers that are larger than or greater than 15. So for number 8, we have x's on opposite sides of the equal sign. So I'm going to first move my x's together. It's easier to move the smaller to the larger, so I'm going to add 2x to both sides. Okay, that's going to cancel these 2x's out here. When I bring it down, I'm going to bring down my 9 is less than or equal to. 6x plus 2x is going to give us 8x here, and then minus 15. So now, in order to solve for the x, I'm going to add the 15 to both sides. And when I do that, I'm going to combine 9 plus 15, which is going to give me 24 is greater than or equal to 8x. And then now finally I can divide both sides by that 8. So that's going to give me a solution of 3 is less than or equal to x. So when I graph this now, I can start by putting my 3 in the middle, moving a couple directions, or a couple digits in each direction. So to the right we would have 4 and then 5, and to the left we would have 2 and then 1. So I have to determine open circle or closed. It's closed here because we have an equal to sign with it. It includes the 3. But x is greater than. That's where it's opening towards. It says 3 is our smaller number of the two. So that means I'm going to shade to the right to show that x is a number greater than or equal to 3. Alright, on number 9 we have the same thing. We have x's on opposite sides of that equal sign. So I'm going to start by moving the smaller to the larger, and the smaller one here would be this negative 1x. So I'm going to add plus x to this side and plus x over here. That's going to leave me with 6 plus 4x on the left is greater than or equal to 12. So now if I want to solve for x, I'm going to subtract 6 from both sides. That leaves me with 4x is greater than or equal to 6. And then I'm going to divide both sides by that 4. Okay, yes, this is going to be a fraction, and that's okay, so just leave it as a fraction. So we have x is greater than or equal to 3 over 2, and I got that by reducing 6 over 4. So this is my inequality. I am going to graph this. I'm going to start by graphing 3 halves in the middle, and then I can move a couple in either directions. When you move it, just understand that the top, you can change that. So we could say 4 halves and then 5 halves, which yes is larger than 1, but so is 3 halves. And then we have to the left 2 over 2 and then 1 over 2. So again, graphing the same way. It is going to be a closed circle because it does include it. It's equal to. And then x is greater than, so we're going to shade to the right to show all of the numbers that are greater than or equal to 3 halves. Okay, we're going to take a look at a couple now. We actually have to set up the problem. So this one says Fred the farmer has started a savings account for a tractor. He saved $600 last month and plans to add $100 each month until he has saved more than $2,000. Write an inequality in terms of the number of months M that he has to save for the tractor. So what we first want to look at is how much he's starting with. So he's saved already $600. That means he's starting with $600. It says he plans to add $100 for each month. So we're adding 100 plus the number of months that he's saved. So 100 per month is 100M until he has saved more than 2,000. So our goal here is to get to 2,000. And we want to know what more than means. So more than is our inequality sign, and more than means that I want it to be greater than 2,000. So greater than, this is the amount that he's saved versus that $2,000. So this amount has to be greater than 2,000. So this would be how I write my inequality for this problem. And we could solve it from here, but we're just going to stop at this point. Okay, let's look at this last one now. Gabby the Gabber likes to text message her friends using her cell phone. She is charged 10 cents each time she types a message plus $50 for the phone plan. She is only allowed to have a bill that is at most $60. Write an inequality in terms of the number of messages, M, that she can text each billing cycle. So what we have to look at is how much her phone bill is going to cost her. So initially she's charged 10 cents each time she types a text message. So that's 10.10 per message that she types, and we represent that by 0.10 M, plus that $50, plus $50. And then she says that you can have at most 60 for her phone bill. So our goal is to be no more than 60. That means we're wanting it to be less than or equal to $60. So this would be our equation for number 11.